second camera. That's awesome.
Yeah, man, look at me. I'm like all, Zoom ready from my trial by fire. So here's where a good place to start. I have a single sheet of paper here. If you can, as close as you can, fold your paper into thirds, kind of like we're making a tri-fold brochure. So kind of just over on one side, give it a little crease, and then fold it over on the other. Meet that edge. If you have a little edge here hanging off the side, that really doesn't matter at all. If it's not perfect, it's not going to be a deal breaker. But really, what I just want to kind of delineate, three different sections of our paper because we're going to start with one idea up here. We're going to kind of build as we get to the bottom, and then we'll switch over to some graph paper too. So what I'd like you to do, the type of drawing that we are going to be exploring today is called orthographic projection. So orthographic projection drawing, right? Now, orthographic, if we break down these words, the same way we went through and we talked about, morphological chart. If you were to look up, the word ortho, it's defined as meaning straight. You've probably heard that term ortho in other places. Anybody hear ortho come up anywhere in their daily lives?
Orthopedics, orthotics.
Orthopedist, yep.
Orthodontist.
And orthodontist, very, very prevalent in my seventh grade class, right? And they both have practices in medicine that an orthopedist helps bones heal straight, and orthodontist helps teeth become more straight. So I'm going to explain what this means, and it's going to still make absolutely no sense unless you already know. So just bear with me on it. So ortho meaning straight, graphic, a type of drawing, a visual representation. And to project something is going to mean to go from one base point to another. So that's the meaning. And if you have never done one before, you still have no idea what I'm talking about, but we're going to stitch this all together. In the upper third of your paper, so like I've kind of got like, if it's a little tough to see, I'll just kind of do a light line here. In the upper third of your paper, based on what Chris was showing us last week, I just want to do what's called a thumbnail sketch. Maybe in just the upper area of our paper in the corner over here. Let's do a quick thumbnail sketch of something that we all need and use, a coffee cup, right? If you can give us just a representation in this upward corner of a coffee cup, drawing on what Chris, get it, drawing on, pulling from what Chris taught us last week, you probably are going to do something kind of similar that shows a round shape, maybe something, depending on the type of coffee cup that you use, it's got maybe a handle on the side. And it's given us a lot of information in a quick little thumbnail sketch. We really didn't, think about sizing or anything like that. But from a quick thumbnail like this, I really have a lot of information. I have information regarding proportion. I have information regarding shape. And it's a three-dimensional, a 3D drawing, just as the simple sketch. So I'm showing three different dimensions here. I'm showing a z-axis and up and down. I'm showing an x-axis in one direction, and I'm showing a y-axis in the other. So I'm seeing the length, the width, and the height of the coffee cup, even though this is just a quick little thumbnail sketch. So what I'd like you to imagine next in this area over here, somewhere in this top area. And again, this paper, you're not turning it in. I'm not going to make you share it or anything like that. It's okay if it's, not up to whatever your standard might be. But I want you to consider what this coffee cup looks like if we're only looking at two views or two dimensions, only one singular view, a side view. So blue axis, maybe red axis, or blue axis and green axis. If I am looking at this coffee cup, it's sitting on the table. What does it look like from a side view? And as you start to consider this and you start to sketch yours, I'm going to sketch the three versions that I see most often, without, walking around and looking over people's shoulders. If I was in my class, I'd see things that looked a lot like this. So I might see something that looks like this pretty commonly. Might see something that looks like this. And I might see something that looks like this, most commonly, right? You might have something, a variation of one of these or a merger of both. But instead of, putting up a poll on the Zoom meeting here and asking people your thoughts on, which of these is the appropriate side view, let's just talk about why B is correct, right? So looking at A and C, if my coffee cup in a side profile had this bottom curve, I'd have a very difficult to balance coffee cup, right? I have the coffee all over my desk. So that's not A. C has the same problem, but also the curve on the top. If our coffee cups on the top don't have one part of our rim higher than another. If we actually looked at this from the side view, we have a flat bottom and we have a flat top. So that view B, the option B for our side view, is what we're actually looking for in something like a coffee cup. Even though our mind wants to tell us and the other people, especially having come from isometric drawing, that this is round. Absolutely right. But it could also be rectangular. There's stranger things out there, right? But we don't need to know that in this view just yet. So what's going to give us that information is the view of our coffee cup from the top down, right? So what I'd like you to do also in this space on the upper third is show me a top view drawing of our green and our red axis. If we were looking straight down on the coffee cup, if it was right here on the table in front of us, what would we see?
Like a layman's term bird's eye view?
A bird's eye view, or the helicopter view, the view from overhead. Exactly. So most folks, are picking up on the coffee cup is round, right? So we're starting usually with, the circle. And, some folks make a little judgment on the handle off the side here. Some people go even a little bit further and they might actually show that there's a rim around the coffee cup. Now, maybe there's even a little bit of coffee in there, right? Not part of a technical sketch, but it's there nonetheless. But the one thing that not everybody has done, if you've never done one of these drawings before, is the top view being directly over the side view. So I put it here. I did not give you the instruction to do so, so don't panic if you didn't. But my edges line up with my edges. My handle lines up with my handle. So this graphic is projected from this view to the top view straight, orthographically. So that's the genesis of where orthographic projection comes from. That's what it means. It means to show these multiple views of the drawing lined up in a straight formation. Universally, if we are passing this drawing, not necessarily this one, but maybe one that has a little bit more detail off to somebody to build, it is universally understood that if I have an orthographic projection drawing, whatever is up here is the top view of that side view, right? And this has a bunch of different benefits that we're going to look at here as we go through. So that's the end of our little introductory third. So let's head down into the middle section here, the middle section of your paper. Anybody have any questions, comments, use it in class, anything they'd like to add? So let's do like a little, pop quiz, right? So we're understanding a little bit about, two view drawing. Orthographic projections can have more views, and we'll talk about that in a moment. But for this center section, I'd like you to take, just a couple minutes and draw for me an orthographic projection drawing. Right now, only two views of a quarter, a 25-cent piece of United States currency. So you can take a moment and draw your version of a quarter. Doesn't need to have super duper detail on the coin face, but anything that you want to put in there is fine. And most of us, probably are in agreement that the quarter is in fact round. Chris's circles are much nicer than my circles. And, maybe you went through and you did a little George Washington on here. Maybe he's got a little ponytail back there, something going on. Maybe you put a year on here. And maybe it's got some writing along the bottom or some writing along the top. But we kind of, are in agreement that is going to be at least one of our views. If the quarter is sitting on the table, we'd probably consider that our top view, right? And just like we did up here, there's usually a couple of different versions of what the side view for this quarter might look like. So I'm going to draw those versions in here, and we'll see where you fall and which ones you might think are correct. That one might be one. See something like this, more like crescent shape there. That'll be our second. And then sometimes I see something like this come out of our students. And call that design number 3, right? So hopefully, after going kind of through some of this on our first third, we gave some thought to what this quarter might look like, when it's laying flat on a table, right? So if we took drawing C and we put it flat on the table, it would sit there kind of like a football, and it might rock up and down, and that's not happening. So C's out. B, same idea. It's gonna rock. It's got like a little cereal bowl look to it there. The coins don't sit on the table like that either. So if you had something like A, you had the correct side view. And bonus points if you actually projected it, if you went and lined up your edges. Now, let me tell you what doesn't matter on this circle, on this coin, and what does. You might have this design, this edge, this A profile in this orientation down here. And in that case, you got the right profile on the side view, but this really needs to be rotated so it looks more like this. It doesn't matter on this particular shape what side view we're looking at, as long as it is projected. It should be the same width from the top view to the side view. So that should transfer. If you're looking at a shape and you go, oh, well, that one's much, much thinner, there's probably something wrong there, right? So we have our, one of our more common misconceptions are round objects. So that's why we start with like the coffee cup and the coin analogies. So for the last thing I'd like you to do on this particular paper, this time we're going to take the drawing just a little bit further. And this time we're going to do a minimum of 3 views, okay? And the 3-view drawing that I would like you to create in this lower section should be of a smartphone, okay? Any make, any brand, anything that you are familiar with. How many sides does our smartphone actually have?
Jim says 6.
Oh, cool. All right. I couldn't see the chat there. So yeah, it's 6. It's like a cube, like what Chris was showing us last week. So 6 sides on our phone right now. I'm going to be reasonable. I'm only going to ask you to do 3. Now, as we start to look at, what this phone might look like, most of us start in the view that we stare at a lot of our day, right? We're looking at that face view. I recently updated my iPhone, but I'm having a hard time without my home button. So I'm going to put my home button there just in mourning and in solidarity with the folks that are old school, that can't quite get used to gesturing. Other things I might see, phone doesn't have to be on, but other things I might see are my speaker up here. Maybe I have my front-facing camera. Maybe I see my screen here. That's like my facing view. That's the view that most of us spend most of our time staring at. Depending on, your model of phone and what your brand is. Your tops and sides might look slightly different. You know, my current phone has absolutely nothing on the top. It's got no controls, it's got no buttons, nothing on the top. The bottom got the little lightning port in the center. Maybe there's a speaker on one side. And then just as a throwback, I'm going to go ahead and put a headphone jack there. You know, there was a period of time when Apple removed the headphone jack that some YouTube videos surfaced, and they swore that the mechanics were still there. Go ahead and drill a hole in the bottom of the phone, and you don't have to go to AirPods. And people did it. It wasn't true. Don't drill into your phones. Side view over here. When I look at what is considered on this drawing the right-hand side view of my phone, that's where the new power button is, right? Now, if this button protrudes, I would actually see it kind of lined up in this view. So I've got like a projection going there. My other side, I've got my mute, and I've got my volume up, and I've got my volume down. So those might come out the sides a little bit here. And then just because I'm on a roll, I know I only asked you to do 3 views. I'm gonna go ahead and do the back here. And you know, the back of the phone has that new amazing camera with all kinds of different lenses and lights and stuff, and put the world's worst apple here. I'm sure Chris can do a better apple. Mine looks more like a tooth. We got that set up there.
You're cracking me up, Ken. But I have my microphone off.
Well, thanks, Chris. It's been a while, right? So yeah, I cling to these old things. I'm having a real hard time without the home button. That's really not a joke, and I appreciate you laughing at my misfortune. So we've got 6 views now here of our smartphone, and by now, you know, we've talked about orientations and we've talked about lining them up. We know, because design standard tells us so, that if this is an orthographic projection drawing, what I see in this view is what I can't see in the facing view. It's what's directly above it. So I'm getting a lot of information out of this. I don't know until I see that top, these sides, or this bottom, whether my phone is a 1/4 inch thick or is like a brick. You know, if it's 3 inches thick. I don't know until I have that information, right? So speaking of information, this is when we're going to start to talk about what some of the rules and requirements are for orthographic drawing. So the first one we're going to talk about here is dimension lines, right? So this could be the actual size of the phone, or this could be a massive stored display. You know, if we don't have our students dimension their work, you know, we're not going to know which is which. So let's just talk about what a dimension line is, where they belong, and where they're appropriate. So a dimension line is always drawn separately from your drawing. Should never have dimensions over the top of your detail.
In every math book I've ever been in, when they're showing a circle, they write the diameter dimension right across the center of the circle.
Right. They're also not trying to show detail inside that circle, though, right?
Right.
Were you going somewhere with that, or?
Yeah. Well, what would be why wouldn't we be able? Why in these drawings is it that you can't put dimensions over top of the actual object itself?
Are we asking this for the good of the group?
Yeah.
Yeah. So what are our thoughts on it?
One of them, you can cover up features that don't want to be corrupted.
Totally. You're trying to show off with the object. You can't put dimensions over top right on the object lines you just drew, because it might hide something. Yep. And if somebody gave those plans to the next person to produce the object, they might think that number 5, you know, if you said the diameter is 5 inches, you drew it across, they might think you're supposed to engrave that into the surface of the phone, or that it's a graphic that gets put on the phone, right?
So what we're getting to now, and Chris actually just kind of like said, there's a couple of different types of lines that are going to be useful when we're doing these types of drawings. And then Kathy, I see your question too, and I'm going to show you that also in our next piece about the indents and stuff like that. So this next type of line, so the first type of line that we're going to talk about is this dimension line, right? And dimension lines, and you'll see in a minute, part of what Chris and Jim's point is here, why they should be separate from our drawing, is that they hold this information, but they also take up space. They'll terminate with arrows, right? So let's just kind of bring this in a little bit here. They terminate with arrows. Get a little better focus on this. Usually got a gap in the center here. And then whatever size our phone is what we'll put in that gap. I'm going to back this up a little bit because it's getting a little fuzzy. Now, one of the values of this type of drawing now is that this dimension line is good for this side, this face, this side, and the back side, because they're all lined up. I don't have to dimension every face separately. So the same thing would be true if I did a dimension line this way. And I don't know, that one might be, 2¼ I'm making it up, right? If I have an area like this where it's a little too tight to put my dimension line in, I might put a little call out there with my size. Now, the important thing is when you're adding dimensions, we want to make sure that they're always oriented to the viewer. So we don't want to have like one dimension, switched around because it was on this side. Numbers should always face the same way, and so should your text, right? But now to the point of where, Chris and Jim were just talking about the clutter and the features, if this was an actual cell phone drawing for the Apple Corporation, there would be hundreds of dimensions on this. They would want to know the size of this button, the distance between this button and this button, the radius of this edge, how far is the screen, how wide is this speaker, where's the center of this lens from the edge of this radius. And all of these pieces of information are going to start to cloud up over the top of our drawing. So, in some CAD programs, we use layers, that allow us to see certain information. But on a hand-drawn sketch like this, we might, bring some of these lines out and put our dimension lines in areas that don't obstruct any of our other drawing information.
Ken, can I share my screen real quick and show people an overwhelming picture of a professional orthographic sketch for the body of the cell phone?
Yeah, I think you actually showed it briefly last class. So go ahead. Show
me. I did?
Yeah, but it was only for 10 seconds. So put it back up.
I'm sorry.
No, don't be sorry. Do it. It's highly relevant.
Now, this picture I'm about to show you, it's the orthographic for all 6 views of the phone, as well as magnified views that show off some really small features. They also portray it in isometric.
There's a lot going on there.
Now, in the assignment, I say no. You can't draw a cell phone, but only because we've talked about it so much in the lesson, not because it's too tough to draw or anything like that. But from our lesson we were having here with Ken, we would never be expected to have the mastery to be able to produce this type of orthographic, right? But this shows you the level of detail that goes into it. And I think in like a high school engineering course, if you're able to spend 2 weeks on drawing in one of your courses, you could get to this level for sure. But when we only have time to give, in a curriculum to teach this type of drawing for one day, we wouldn't be able to expect somebody to come up with all of these different dimensions. So you'll see in the assignment that it asks for you to do your best to dimension as many of the features as you can. But remember, the time limit on this assignment is 90 minutes.
So I was under the impression, falsely or erroneously, that an orthographic projection was just 3 sides. It was top, front, and right side. Where did I get that from?
Well, I mean, that's usually a standard minimum, right? But if you were
Yes, and if you were to take the three sides, there's a way that you can project. If you have your top, front, and side view lined up on your paper in 3 of your 4 quadrants, let's say, there's a technique where you can draw a line from each of the 3 different quadrants toward the 4th quadrant, and then connect the dots and turn the 4th quadrant into an isometric. I think that's where that term projection comes off of 3 views.
And now that's also, that's fantastic, but there could be important information on one of those missing sides. And it could be one of the views that you don't see on the isometric either, right?
And I also was under the impression, and I mean, it looks like this still may be the case, that it all had to be on all the sides had to be on a 90-degree angle. Is that true?
On a 90-degree angle.
Yeah, like all the bottom of all of the faces are the same place, like.
Yeah, point to point should all
point
line
to
up.
point.
Yeah.
I guess.
So they shouldn't be like floating. Your side view, like where Chris has his magnifying glass right now, that bottom edge should line up with the bottom edge of the front face, the other side, and the back.
And it does. So this corner lines up with this corner, lines up with this corner. So if this was a side view, front view, bottom view, these 3 views would go point to point like this. That's what you mean by on a right angle, I think, right?
I gotcha.
Where you could look at it from this corner to here, if you're just taking these 3 views.
May I show something that I just had a student draw?
Absolutely. You have the ability to share, or do you need let me see if I can make this big for everybody. Stand by. Spotlight. Nice.
So that's what the views align together, top to bottom and left to right. And the dotted line is representing a feature that's hidden in one view. The next thing these kids are going to do with this drawing is going to dimension it. And then we're going to call out a couple of material choices. And then from here, we're going to go into AutoCAD and then into Inventor.
Nice.
A nice, crisp, clean drawing there, Jim.
So this is
and that type of drawing where every line is done with a pencil and a ruler, no matter what, is our expectation too. We just do it we're just doing it fast right now.
Now time out.
Didn't quite get to that point. We're getting there.
This is on vellum, and they use the Sharpie marker. So it was one time and one time only to get it right.
Wow. Jim, you're not as forgiving as we are.
No, not with this kind.
Ha! I'm going to de-spotlight you since put that down. Hang on one second there.
I'm sorry if I wasted time.
You did not waste time, Jim. As a matter of fact, what you did do was you tipped our hand a little bit as to what's coming next, right? So you just showed us this this amazing student work that has a couple of other items that we haven't talked about yet in terms of the types of lines that are required and expected. And the first one that looked a lot different than all of your other lines was this this hidden line, right? So we have a few different features to talk about here, and I'm going to switch to graph paper for this. And I'm going to switch to graph paper for a couple of reasons. Number one, I don't have a ruler handy, right? But for our purposes, anyway, with the demonstration, that's not 100% necessary for this particular drawing. But I brought this nice little piece of walnut from school today, and to show a little bit of information about the value of orthographic projection and kind of what we were just talking about. Let's draw this together, right? So without worrying about size specific right now, that's not important. I am going to represent the side view of this piece of oak.
Red oak.
What's that?
Red oak.
Red oak, baby. Smells great. I'm going to represent this piece of oak just with I'm actually going to, because I'm angry that I didn't bring my my ruler here.
The table's made of cherry, but that piece is oak.
Well, that's the thing. I have several pieces of wood here because like this is my wife's like desk, like antique desk, and if I get Sharpie on this thing, like I don't know what this is, but it's whatever it is, it's 100 years old. So I'm trying to mind my P's and Q's. I guess I'm going to have to go freehand, even though I don't want to. So I'm going to represent the side view of this piece of red oak, like this on my graph paper. And like we were just talking about, even from your view right now, you can kind of tell that this piece isn't, a foot thick, or, it's not something that's totally out of proportion to what we're looking at here. But I don't have a lot of other information on it, just yet, right? Mm-hmm. So if I wanted to take a look at this from the side view, I'm going to put that view over here. Now, one thing that we got to be careful of is when you lay out your orthographic drawing, you want to make sure that you have enough room on your paper. You don't want to be like, oh, I want to leave an inch in between here and then go right up to the edge of your paper. So make sure that you're planning out accordingly where you want your other line to go. So if we were to look at this in the upward view here, we have our square. So I'm going to put a square here.
Ken, if you could humor me for a minute and lay the block back into the side view, the first view that you drew, and lay it right on top. Okay, and then now from that position that it's in, mm-hmm. if you were to pick the left side of the block up, but leave the right side of the block pinned to the ground. There you go. Yep, do that flip for us. All right. How many degrees did Ken turn that block of wood to get it to that position?
90.
90. All right. So now, and so he made a 90-degree flip, and that gave him the view right next to it, right? Yep. Now go back to that other position, to the original position again. Yep. Now make a 90-degree flip toward yourself. Oh, look at that. Now we have the other view. I know that's what you're going to next, Ken, but I just want to add that the word orthogonal means perpendicular to, right? And so that's where we get I think the complete meaning of that word is both pieces. These are head-on straight views, and each view would be perpendicular on the plane to the previous view.
This actually should be this way, but we'll talk about that in a second.
That's all.
All right, so
like saying to kids, like if you would like turn it now, and if you had an ink pad and you would like stamp that side and stamp it onto your paper, what shape would it be?
Exactly, almost like a shadow view, right? Mm-hmm. That's a great way to explain it, Lauren. So through the fumbling of the block, I tipped my hand here a little bit and showed you that there was some information here that I wasn't giving you ahead of time. Just have this little notch out of the center here. So that information, while not viewable in this view, is viewable in this view, right? So I'm going to take my same, oops, shouldn't have done that. And I shouldn't be doing it in Sharpie. Went the wrong way.
I do like how you're spacing the three views with two of the blocks on the graph paper between each view. Mm-hmm. I know there's a rule for exactly how far they're spaced, but we don't care. We're not worried about it. But if we're just consistent, like you are with the spacing, that's great.
Right. For our purposes right now, where we're at.
Yeah, there's like a 45-degree angle that you can make, and then you can project the lines from you can project the lines from the top to the side then.
If I was in Jim Kennedy's class,
yeah,
and I did this with my Sharpie marker, I'd be starting over.
Yeah.
Right, Jim? They don't have an option, right? Like
there's no option for that.
No option.
Oh, I love it.
So that Jim Kennedy, he'd take me down a peg if I turn that in. But now here's where the important part is that we're kind of leading up to here. In this view, even though it doesn't tell us on the object that there's a void here, right? We show that in this top view with another type of line. So the lines that show our objects, the way they look, are called object lines. The lines that show a feature, and you saw this on what Jim had shared, are called hidden lines. And hidden lines are shown in a dashed pattern. That tells the person that is looking at this drawing that there's something going on behind here. Now, they don't really know what it is yet, right? Like it could have a radius, it could have a U shape. They don't know, does it go, to within 1/8 of an inch of this wall? They don't know what's going on until they see it in another view. And then when this hidden line shows here that my object line shows that this is all the way through, my hidden line shows where it goes up to, I can determine that there's a void inside of this block. Now, if we flip this again this way, what we're looking at here now are going to be object lines as well, right? So the object lines that we have on this view are going to be, and forgive my wonkiness here. We see 3 faces here, right? I'm trying to get a little bit of light in here. We see 3 faces. We see the inside, and we see the 2 that are closest to us. We show that with these object lines because there's nothing hidden in this view that we've talked about yet, right? So there's one more view that we're going to take a look at here. We know what this looks like in this view, and we know what this looks like in this view, and we know what this looks like in this view. From our very top, I put a little hole in the top there that also doesn't go all the way through. So we're going to represent that a couple of different ways on here. My top view, or my whatever view we want to call this, is going to look very similar to this because my exterior object line is going to be the same, right? So I'm going to have a point here. It's going to go from here to here, to here, to here. So that represents like the one edge of that opening. And then I've got my from here to here. This is coming all the way down here. And I've got that top view on here now, right? But now somewhere over in this area, if I had my ruler, we can look at that center point. We're going to call it here. I have this circle. And I have that as an object line because I see that edge. So this is actually going to show in my other views as well, but it's going to show in different ways. It shows in this view as a hidden line because there's a void there that I don't see. I know it's there now, but that shows where that void comes down. I'm going to see it in this view as a hidden line because I don't see it overtly, but I do know that there is a void there. I'm going to see it in this view, even though I don't see it as an object line in this view. And I'm going to see it in this view as a hidden object line, or a hidden line rather. So this gives me all that information. We've talked about our object lines. We've talked about our hidden lines. There's a couple of other things that are listed as requirements on your assignment that I want to hit you with here before I kick you back to Chris.
It's okay. If you don't have time for them too, you can always, if you have to run, you can run anytime. Are there dotted lines we're missing in your right side view?
There are. Who knows what I need to show? Very good, Chris. I had left that off on purpose, and I'm glad somebody was paying attention.
I know you did.
Who knows what else I should be seeing in that right view?
The cutout of the legs, the whatever you call those.
Yeah, whatever we want to call these, there's a void happening behind here in this view. Good job, Chris.
Perfect.
Good job. So now, object lines and hidden lines. We've talked a little bit about dimension lines. So I'm going to drop a dimension line in here, separated from my drawing. And I'm going to, so 1, 2, 3, 4-inch dimension. If there are certain things that are important about maybe the material or a process, or perhaps, you know, it would get a little bit more complicated. But if we had like a bevel here in our top view that kind of let this come down on an angle, you know, maybe something kind of fits in there, I can label that using, what do you call it, Chris? A call out?
I call it a leader line.
A leader line?
In the
So-
assignment, I wrote it rules. I wrote it as a leader line.
So if you want to give a piece of information to the person who's viewing this, your leader line is going to come off at a 45-degree angle. And then you're going to give some information here, you know, about, well, you know, this is going to be a 1/4 of an inch bevel, right? Or maybe you're labeling, you know, a specific material. Maybe the inside of this is lined with felt, you know, or something to that effect. And I actually broke one of Chris's rules, right, Chris?
Yeah.
All caps when you're writing your call outs or any other information. So we talked object lines, we talked dimension lines, we talked hidden lines, we talked about views and orientation of views, we talked about all caps, and we talked about leader lines to show information. What else do you think they need to know as they move into this assignment, Chris? I think that I kind of went, and obviously, of course, I only put one dimension on here, but you'd be dimensioning all your necessary dimensions. You know, how big is the leg, or the, you know, whatever we're talking about here, the gap between, you know, how deep is this hole drilled, or, you know, those types of dimensions also belong on here. I'm just not going to take up all your time doing that right now. But
I think this is awesome, and I'm actually, next time I teach orthographics myself, I'm going to steal your introduction here with this block. I really like this, and you definitely made introducing this set of rules more simple than I would have. I do have some stuff I'm going to follow up with after you go.
Mm-hmm. Well, I'm not running out of here. So.
Okay, cool.
Yeah. So, does anybody have any questions about anything that we went through? Kathy, I answer your question about indentation, right? With the hidden lines and object lines? Okay, I don't think I had any other questions in the chat, right? Oh, do we have?
Lauren asked about center. Lauren asked about center lines.
Yeah. So you want to field it, or you want me to do you have?
I don't require them in the assignment, but you might as well explain them so people know when they see them on a print somewhere what they mean.
Do you have them on that orthographic of the cell phone? Is there any on there?
Yep. You know, like maybe the hole that you just put in the top, like the center line would be used to like dimension, to know where that hole is drilled in that.
Yeah, we can zoom in.
Shape.
It's almost like there you go.
A cross in the middle of it. And then you dimension to where the center of that circle is, because when it's manufactured, like that's where maybe your drill bit is going to go into.
And I love that it has a home button.
Yeah, they put crosshairs basically between between the center point of every circle, so that you know it's a perfect circle. And if an object is perfectly symmetrical, which a cell phone is not, because there's buttons on one side, they're not in the other. But if it was perfectly symmetrical, they would put a long line, quick short line, and then long line down the center of the object. And that lets you know that that's a center axis that could be rotated around in the same all the way around.
And then I
imagine Jim teaches these in his class, you know.
Yeah. And you can dimension to center lines, but you're never supposed to dimension to hidden lines. You should dimension on the view that has the actual line.
That has the actual object, right? I mean,
yeah, like I could see they put 29.28 for the distance between the center of this button and the side of the phone. And even though that itself is not a feature, the button's a feature, the phone, the shell of the phone is a feature, they're still putting a dimension for the distance between those two features as a reference.
But so they that can also show, I'm sorry, go ahead.
just so that there's nothing to be assumed in the drawing, because when they're manufacturing, they're doing it to a thousandth of an inch tolerance. So you need to know the spacing between everything so that the machining, the machine that's cutting this stuff out has reference points.
Now, what they might show in the hidden line view, in my example with the with the hole drilled there, would be the depth of the hole, right? It's a different dimension, but you wouldn't know from the top view, the diameter or the radius, how deep down that hole actually is supposed to go. So that dimension we might show on a dimension line, but you wouldn't dimension your radius or your diameter off the dimension line. You'd use your object line for that. Anything else, guys? All right, Chris. Well, that's what I have for them. Might be a good time. I don't know how you feel about maybe pulling up that orthographic assignment. It might tie in good at this point, or if you wanted to add something else yourself.
Yeah, I was going to go on for like maybe another 20 minutes with this myself. I just have to set my camera up.
All right. You need me to stall for time here? You want me to tell some jokes?
No, if everybody just wants to take 5 minutes and relax while I set my camera up, that'd be cool.
Take 5.
Kenny, what is why is it the rule for all caps when you're labeling?
Lowercase gets to looking sloppy, I guess. And so the architectural font is what you see emulated. That's the font that's always written in all capital letters. And
Chris,
yeah.
Correct me if I'm wrong. Weren't you developing your own font years back?
I forgot about that.
You did though, right?
I think so.
I seem to remember you had when you would do this lesson, you made your A's a certain way, and you had it was a very unique look. You could always look at a drawing without even looking at the title block, which I actually probably should have mentioned, but we can mention that when we go over the assignment. And I could know whose drawing it was because Chris used to write in a very unique font that he created that he would write, by hand. And you could always tell if somebody's making A's like that, this definitely came from Anderson. That was a thing though, right? I'm not imagining it.
Yeah.
Okay.
I had lots of ideas I never carried out all the way.
You let that go? You had your own font and you that's disappointing.
So let's just take 5. I'm going to turn. You guys can turn your cameras off if you need to, whatever.
All right. I'll come back at 5:40.
Yep.
All right. 5:40.
Awesome. Thanks, Ken.
All righty.
So if you want to send a text or something, just say I say happy birthday too, okay? All right, I'm gonna go for my last walk. All right, bye-bye. Hey, it's me. I wanted to say it's Jody's birthday, so if you wanted to send a text or something, just say I say.
So I'm wondering if on the other, not in the gallery view, but can you see another screen where you're looking at my hands over the paper? And am I in the top corner?
You're in a small box. Your hands
Okay,
in a
great.
large box, so it's probably exactly the way it should be.
Okay, cool. So when it's bright, you get 160. You got to spend $160, but you can get a really bright light. All right. So I'm just going to give us a chance to do some guided practice now, where we can try a couple different things, and I'm not going to add any more rules than the things Ken went over, but I'll just reinforce them a little bit and show you a couple little nuances to these drawings. So again, I'm not on graph paper, and I do have a marker in my hand instead of a pencil. And that's only for the sake of time and contrast. But in your assignment, you'll be on a piece of graph paper. If you can orient it in landscape view, it can be helpful. If you have a piece of graph paper as large as 11 by 17, that's awesome. If not, we'll take it on whatever you got. Doesn't matter what size the grids are, if they're little itty bitty centimeter blocks or if they're 1/4 inch blocks or whatever. Typically, I would take my paper and I would probably separate it into 4 quadrants. That's often how we see these projections. And, you know, you're going to have your 3 views in 3 of these quadrants and another quadrant left open. You'll often see the isometric thrown in that 4th quadrant when you look up pictures that maybe somebody have printed out from their CAD software where they design something and they go to shoot out the prints. They'll often show a top, front, side view and then show the isometric in the same document. We're not worried about that. We just want our top, front, and side view. But I want to say something about the pencil. So most people are probably holding a mechanical pencil, or maybe you got the Ticonderoga #2. Yeah. Do you know where the #2 comes from, or what goes on with pencils and these numbers? Anybody have any background information for us? Why is the #2 the one everybody holds in their hand in school?
It's the hardness of the lead.
It's the hardest of all the leads in the different series. How many numbers do they go to, Jim? There's number 1, 2, 3.
I have 3 mechanical pencils I give each kid. It's 0, 0.5, 0.7, and 0.9. It's also got the diameter of the lead. Wow.
Yeah, so I feel a little inferior, Jim, because you know much more about this topic than I do. No, I'm just good at summarizing it into a format where it's enough for a short lesson to reproduce. But when it comes to the #2, this was selected of all the pencils, like Jim said, because we use them on Scantrons in school, right? So it's effectively a choice was made because it's the quickest and cheapest way to create a snapshot of student achievement across the country so that they can appropriate federal funding and state funding, right? That's why we all hold on to this #2. But there are other pencils, like Jim said, and the reason I had all these pencils is because if you were a drafts person, you were creating prints, each type of line or symbol or the notes you make, all these different ways that you mark your paper, each have a designation for a different pencil, all right? But we don't have all these different pencils, and I can't expect you to be able to do what Jim has with at least 3 different pencils. So what I try to tell students is there's going to be a few types of lines, like Ken said, that we're going to use, but we're going to have to do it all with a single pencil, and we want to be able to distinguish between the different lines. All right. So I have a little oil can right here, and maybe what you could do on your paper is just like Ken has shown us already. If you could map this oil can out in 3 views and make your views be aligned, it doesn't matter. As long as they're in alignment, you'll always have 1 quadrant open. And the way this thing looks, it's a oval shaped can. It's got this pointy part here, a little round protrusion there. So it's not perfect, but just see if you can map this out and align the views. And what I want you to do is for these object lines, we're going to make the pencil stroke nice and dark for the object itself. it doesn't seem tedious when you're doing it freehand, but when you're using the ruler and you're using the rule and the graph paper and the pencil, and you're trying to make everything perfect, it does get tedious. And that's why I have to remind students that just like you may have stamina for writing a paper or for reading, you'll have to build up stamina for doing technical drawings too, because it's something that it's a muscle you don't work as often. I'm embarrassed by this, but reason being, now that I've got it laid out. What I would add to my sketch, like with the dimensions next, if I did my object lines with a nice dark pencil stroke, then when I make my dimension lines, if I'm super intentional to make contrast by making a very light pencil stroke for the dimension lines, then when someone looks at my paper, they can clearly distinguish between dimensions and object lines. I got the contrast by having a marker and a pencil here, but you would use a really light stroke with your pencil for the dimensions and make sure, but on object lines, make them nice and dark. All right, so just a little nuance to Ken's lesson. And if we were doing a leader line, and remember the point of these sketches is that somebody could pick up your orthographic, and from the orthographic they could go into a shop and reproduce exactly what you had designed on paper, which means that you can't assume anything. You have to put as much detail information into it as possible. And that would include things like what materials are made of, or if there's functionality here that we need to be aware of. And so again, you can only go into as much depth as you have time for in 90 minutes. But once you've got your objects and your dimensions out there, then you want to start thinking about other things you can include, such as annotations with a leader line that might suggest that would show off the materials that something is made out of, or the functionality. And so if this can was made of tin, I might pull a leader line off of the object itself and let people know that I come off the leader line, like Ken said, I could do it on a 45-degree angle. If that's not possible, the next angle they go to is a 30-degree or a 60-degree. But and then I put a tail on the end of it that I can write a note onto. And that's, again, my annotations are always in all capital letters. Some people, when they write in the all caps font, they'll even put the ruler underneath themselves and try to hit the bottom of the ruler with each pencil stroke.
I tell all my kids everything they write has got to be an 1/8 of an inch tall.
Cool.
You want to see something out of control?
I imagine you had to teach measurement first. Did you have the students make a ruler for themselves before they did this?
I do something called the big inch.
Okay.
And I have them break it down because they get absolutely flustered. And I give them an 18-inch ruler. 0 to 1 is in 30 seconds, and 17 to 18 is in 30 seconds. And between 1 and 17, it's in 16ths. So that throws them for a loop.
Yeah, I could tell you, I have a number of buddies who, because of the Carpenters Union's test, because they couldn't get their head around fractions as a kid, and then had this thing where they, what's that called? Like a misconception that you'll never get it. So anytime you encounter it, it's like, oh, can't do this. Kept them from being able to be in the trades.
Yeah.
They needed somebody like you to teach them how to use the ruler properly and understand the fractions. another thing that I would do in here is I would put a title box somewhere. That's just a standard thing. It's a box somewhere on the paper that is carved out that I put information about the information and that I need to tell people. For example, Jim probably has to put his title box in the exact part somewhere, make it a certain size. As long as it's a little rectangle, it's carved out somewhere. That's helpful. And so in my title box, I can put things like a line where I might put my name, a line where I could put the date. I can put the name of the object or the subject that we're drawing. And the last thing I might want to put in inside that title box might be the scale. The scale. So if you try to draw your home for your orthographic, the home definitely wouldn't fit 1-to-1 on the paper. So you'd have to figure out, however it is that you're going to draw this house, what does one square on your graph paper actually represent in real life? So I might actually shade in one of the squares and say, hey, one of these squares, which I know is a 1/4 inch on the paper, but in real life, one square might be equal to X number of feet or inches, you know, and you would just dictate the actual scale there. And that's just one quick math conversion you can do. I'm not going to be trying to check your conversion, but people also write the scale out as a ratio. How's that go, Jim, in a ratio? I put there, like if this was...
If you go 2:1, that means you're drawing something that's twice the size of a real object or your 1-to-1 scale. Or conversely, if you do 1:2, it's half the size of the actual size.
So 1:2 would mean that my pictures are half the size of what they are in real life.
Yes.
So half of real life. And 2-to-1 would mean that it's twice as big as real life. And so if I had something like as small as this oil can, it easily fits on this paper. I could do a 1-to-1 scale probably, right? But if the object was any smaller than this oil can, I might actually draw it in a larger scale so that it's easier for me to show the details. Because the thickness of this can, I don't know what the thickness of this tin is, but it's probably at less than a 64th of an inch or something, right? And so if I was being exact in my picture, the wall of the can in every view would actually have a dotted line, right? And within there, I'd want to tell people what the thickness is of this wall. And if I can't fit my dimension inside these little arrowheads, I can pull out with a leader line and say how thick that is. So I'm just making the case that this is such a small, tight space to work with. Had I drawn the can bigger, it would be easier for me to show off that there's a wall thickness there. Now, I had a student in one of my classes a couple of years ago, and he was drawing like an Xbox controller. And I never said anything to him about the hidden lines and like how far you should go. And the poor kid had opened a controller up and he was in there with calipers measuring each little piece on the circuit boards and stuff like that and trying to dimension. I thought, oh my God, I felt bad. So imagine, you know, something like this can could totally dimension all the things on it, you know? But if there's guts inside something like electronics and things, don't waste your time trying to dimension all that for us, right? That wouldn't be beneficial for your time. Someone's not trying to reproduce these. We're just trying to see that you can reproduce these rules in your drawings. Another thing I want to say about a pencil is I wouldn't do this with an X-Acto razor because the blade is too flimsy, but this is just a box cutter. And I love, especially in isometric drawing, I love riding the nice squared sharpened edge of a pencil. And I might sharpen my pencil over and over again while I'm doing my drawings because it just gives a cool, like a nice feeling on that fresh edge. So if you haven't ever sharpened a pencil like this before, I kind of dig in a little bit at a 45-degree angle. And then as I push, I scoop a little bit as I push. Now my blade tip, or the point of my pencil, has like 4 or 5 different edges on it. And it just makes for a nice, smooth, crisp line. I definitely prefer this over the pencil sharpener. All right, let's try a paper towel roll. So in 3D, paper towel roll. And this is worth mentioning too, just back to our isometric perspective. You know, you could draw a paper towel roll like this and say, well, it must be an isometric because it's 3D. I've got the curved top and the curved bottom. But the problem with that is we don't know for sure if we're an isometric unless we were to put this inside of a cube, an isometric cube. In which case we would find out that the top of this ellipse up here definitely needs to be much larger and open. It was too narrow before. So that being said, looking at a proper isometric for a paper towel roll, here we are. And the paper towel roll has a cardboard tube inside of it, right? All right, so we're only gonna need 2 views for this paper towel roll, a front and a top, but you get the choice of orienting your front view either up and down or sideways. It would just be up to how you view people approaching a paper towel roll. So if the paper towel rolls are hanging up and like they are in the bathroom in those machines, and you're pulling down the paper towels, you might orient your front view to be wide, where you're showing the paper towel roll wide. If it's sitting on the counter in the kitchen where you're pulling one off at a time, it might be sitting straight up like this. Another thing to see in the assignment is that I request, in addition to not picking a cell phone, not picking something that's a basic cylinder like a paper towel roll or a soda can, because we wouldn't get the luxury of getting 3 views out of it. Just remember, you're going to make your object lines nice and dark. So I'm orienting mine as if I'm in the kitchen walking up to it, sitting on the counter. All right, so as it stands by itself, the top view could be a washer, it could be a donut, it could be a pancake with a quarter glued on top of it. We don't know from the one view, right? Who knows? And even right now, this isn't correct. I need to add more information to this view so that you know that's a cardboard tube. What am I missing?
Could do a leader line.
Oh, I could, yeah, to add a note about the material for sure. But what about the thickness of the paper towel tube?
Another diameter.
Totally. I need a concentric circle inside here. That way there's actually a thickness that I can show as a dimension, right? And so Jim's explained to me, I have multiple ways I could show you the size of the tube and the paper towel roll. The paper towel roll, or the paper towels themselves, could have a width dimension, right? That could tell me how wide this is. And what was the other one, Jim, that would also tell me how wide that circle is instead of using a width?
Well, you could call out that cardboard tube with a leader line. But you could also,
yeah, definitely for the materials. I just want to do the dimensions first.
You could also
be another,
put 4 vertical lines that are dotted to show you in the side view what the thickness of the wall of that cardboard tube is.
Yes, we need that down here. If I was on my graph paper, I'd be doing this with a ruler, and I'd project straight down, do a dotted line, and then another dotted line next to it, right?
And another pair on the other side.
Exactly. And that's what I mean. Most people wouldn't think of that. They wouldn't think of having the concentric circle inside, or that you need a pair of double dotted lines. So just to dimension the width of the paper towel roll, I could tell you down here with a lighter pencil stroke, termination point, arrowhead, termination point, arrowhead, line coming through the center, leave it open in the middle, I don't know, 8 inches wide. That's one way to show the width of the paper towel. If I show it to you here, I don't have to tell you the width up here. But let's say I didn't have this width here. If I took this away, I could have put that width up top here off the circle, all right? But the way I would have to do it is I would use one of these like leader lines, but again, since it's a dimension, it would be much lighter. And I would draw right off the edge there and straight down off the edge of the circle over here, and then make my arrowheads. See, down here, this already comes out to a square edge. So you could just put the termination lines right there, right below it, and tell you the width, right? But up here, I don't have that square edge. So I need to be specific and say, yes, I'm coming off the very edge of the circle. I'm making a light line here, and a light line here, and a light line. Yeah. Say again?
Tangent to each edge.
Tangent, that's the word I'm missing, tangent. A third way I could have told you the width here, a third way I could have done it. You get rid of all these. The width of that circle would be the same thing as its diameter, right? So I could come right off the top of this circle with a leader line that's lighter than the object line. Come off on a 45-degree angle, make a tail, and then I'm going to use the diameter symbol. It's a circle with a line through it. Diameter of this circle equals 8 inches. Hi, honey. You're good. You're good. It's okay. The sound of the doesn't come over here. Next thing I could do is tell you that I could tell you the diameter of the outer circle and the diameter of the inner circle here. That would allow the person to fill in the blanks for what the spacing is between there. So I could have diameter here and pull the diameter off that one, tell you those diameters as well. So if I did that, that would cover up, that would dimension everything we need from that view. But we would still have other ways we could do it to tell you the thickness of this cardboard tube. So this gets kind of crazy, but I could project with a lighter pencil stroke down, straight down, another one straight down, and try to fit my little arrowheads in here. I can't write the dimension in, but I could come off from the dimension line here with a leader line and express the distance between these 2 points. And yeah, I would probably say how many wraps, how many feet of paper there are in this roll. I may say, and I might put an annotation for how many wraps there are. I might put an annotation if this cardboard tube is glued to the wrappings, or if it's just in there with tension because it's under pressure from being wrapped. You can imagine those would be the things that all the other little details that you'd have to provide in the drawing so that somebody else could pick it up and reproduce the 3D product. And yeah, if I was in a class where I was teaching this for more than one day, then I would show that this is a perfect circle with crosshairs, but you don't have to do that. Lighter crosshairs. I would put a straight line, dotted short line, long line, and it would be lighter than the object to show that this is symmetrical. It could rotate 360 around this axis, but we're not required to use those center lines for us. Okay, another thing I'm going to show you to save some time when dimensioning is, I call this a compound dimension. Jim, is there a better name for that? Where if I was going to show this mark, like my Expo marker, the dry erase board marker, that's got the body of the marker, and then it's got the cap on it. And that cap tapers up. And then there's a nub out here. So I need to let people know how long the whole marker is, but I also need to let them know how long the body is versus the cap versus that piece of the stud sticking out. So rather than have 4 separate sets of dimension lines here, I'm going to pull out from each feature. So pull off here. I can pull off from here straight up, pull off from this corner straight up, and pull off this little nub straight up. And then I'm going to put arrowheads in between each one. So they're all on the same long line, but it's broken into 3 separate dimensions. And that would allow the person looking at it to say, well, okay, if you said the body of this is 5, and that leads right into this cap that's 1. And then this little nub, I can't fit the dimension, but I got the arrowheads in there. Let me pull off on a 45-degree angle and tell you that that piece in there was, 1/8 of an inch. Jim, is that term even valid? Compound, is there a better word for that? The compound dimension line that I've been saying forever?
I don't know that word, but the way you dimensioned it is perfect.
Yeah, okay, right. So this way I can have one long line that's broken into then the person looking at this can add it up and say, well, I can add these and I know the total length.
That's right? One thing I don't let my kids do. What you did with the 3 dimensions are perfect, but then I don't allow them to trust the person reading the print to add them correctly.
So you would also continue up
that line. I would wind up making the overall length.
An overall length here.
6 1/8.
Cool, nice. And that seems to be what I see on that iPhone print or projection that we showed everybody. They did this too. And I mean, with this foundation, you could go find a YouTube channel teaching teaching drafting, and you now know enough to jump right into somebody's class, for just series of YouTube videos and take a couple hours on your own. You'd be ready to teach a high school drafting class, as long as you have the ruler and you're familiar with the types of lines. What am I missing in this view, though? For not dimensions, but what else am I missing that I need to express?
I would express your radius.
This little corner here, right?
Yeah.
That's a round dimension of some kind. And so I might need to pull off of here with a leader line and say with an R, radius equals, I don't know what it is, 1/4 of an inch round. And I would probably, this isn't very complicated on the inside. There's a thickness to the wall of the expo marker. So I would need dotted lines going around the expo marker. I know there's a cap that pops inside here from the back. And so that cap would come in. I could see where that slides in. That cap's also a little hollow underneath. So I'd see some of those dotted lines in there. Then you have the filament or the wick that runs through here. That sucks up all of the dry erase marker chemical. And it even the rest of the body here just pops out, double dotted lines. And I would see that chisel tip sticking out, but drawn as dotted lines. And even the cap itself has a thickness. And man, I would look sharp done with a ruler, wouldn't it? Especially if I made the object lines dark, the dimension, anything for dimensions or notes, nice and light, and hidden lines, hidden features with a consistent dotted line.
Hey, Chris.
Yeah.
You can hear me? Okay. What would happen if I didn't want to forget, and I didn't know if you were getting to it, but say there was an object that had in cuts or divots or something, and they were all the same dimensions running down the line. Say it was the pen, and it all had the same in cuts, like I can't think of the word, but cutouts. Would you just do the dimensions of one?
That's a good question. So let's say I had something that had a pattern on it of a bunch of the same holes, but there was 50 of them. I don't want to repeat the dimension 50 times. Jim, what would we do in that case?
I would make an annotation in the
like a Lego block has 6 studs on it, right? You don't want to have to dimension all the studs if they're all the same. There'd be some way to annotate that.
Right, and we can't just assume they're all the same from the picture, right?
So Jim's saying a note that would tell us that all of these are identical.
What I would do, and I tell my kids this, is in the upper right-hand corner, they could wind up, those 6 circles that Chris just drew. I would number them 1, 2, 3, 4, 5, and 6. And up in the upper right-hand corner in my area where an isometric could go is where I tell the kids to write their legend or their key. And they could write holes 1 through 6 have a diameter of, I'm making it up, 3/8 of an inch with a depth of 5/8.
Gotcha. That's cool. Makes sense.
And then you could wind up also saying what the center to center of each hole is horizontally and what the center to center is vertically.
Yeah. Cool.
Thanks.
Good question. We're going to take another break in a couple minutes and take our proper break. Sorry, we missed the 6 o'clock mark on that. Okay. Now, again, these are did I show exploded view before? I don't think I did. You might see this in orthographic if they're trying to show that there's multiple parts that get assembled and from which direction they attach to something. But I'm thinking more so for like a process drawing that the process drawing that you're doing, or in the brainstorming. These other little techniques like magnified view or exploded view could be helpful in giving more information out inside your pictures. Remember when we did the can of soup, right? And I was saying this was me, I did the miso soup and I was saying this was me. And I was trying to show that I was sewing a shirt. I was having you guess the label of the soup. Remember this, right? Did I do this? I did, right? Yeah. But the problem was that in this picture, it's really hard to tell that I'm actually holding a sewing needle. So if in, like, let's say a process drawing, you had some image in there, but you're trying to let people know more specifically what's going on. You could circle something. It helps if you do it in like a different color, like red, or if you make the circle really dark. And you go from that circle, just like it's a magnifying glass, and then you would draw that circle real big. you would start to blow up what's inside this circle over here. Now I could see my arm and my thumb, my fingers holding on to this needle. And you can see the thread. Now we could actually make out that this was a patch on the shirt. I could see that I was stitching it up. So I'd call this like a magnified view. An exploded view is something you probably would see in a lot of furniture assemblies. And you would imagine, like, you know, you take an object, let's say this dry erase marker again, and the dry erase marker has the body, it has the cap that goes on the top, it's got this filament inside, it's also got a cap going into the base. And so if I wanted to show this, how it was assembled and put together, I could draw each piece in isometric on the same center line. There's the cap, here's the filament that runs through and gets inserted into the marker. Down here is the marker itself, the body. And then down here's a cap. And they would put little dotted lines in the open spaces in between that suggest that this thing has if you were to explode it on one line, it would all separate this way. Now, if there was something else on the marker that came in from a different angle as it was being assembled, I would draw that coming in from a different angle, but everything assembles here on one line. If this was a little like coffee table, nightstand next to a bed, and I had the isometric of the stand, however, there's drawers that go inside these holes. The direction these drawers are going to go in here will be on this 30 degree angle, right? And so you might come out like this with dotted lines on the same angle that the 30 degrees are here. You can see in this exploded view, it explodes just like it would go in. This is the way it would come out on that angle. And I could draw the second drawer right under it or something. Let's say this was a changing table for a baby. I was just looking at those recently. It's very similar, except it has those little guardrails that sit inside here, and these pegs, they come off and you can put them on. So there's like each one of the 4 rails has little holes that drops into, and they drop in this way from the top. So I'm showing from here, these come off on this line, right? Up like that. One's over here. And man, IKEA instructions, they got to be good, because the whole business model of IKEA is if we convince you, you can put it together yourself, right? You're the expert, and you're going to do it with just our pictorial instructions, right? And if they were to put those instructions in 50 different languages, they'd have hired 50 different interpreters. They'd have to hire 50 different copy editors. They'd have to print it on 50 different pieces of paper. That's going to add weight to the shipping, right? There's all these costs that get brought into something like that. If they can do it in pictures and in a way that no matter what language or culture you're from, you'll understand them and not be offended by them, right? Because certain symbols can be one thing in one culture, another thing, then you've got yourself an effective business model. Another place I've seen a version of exploded is if someone's trying to say like, what's going into this salad that we're making? And they might say different things are coming in all over the place to here. You've got mushrooms. You've got tomato slices. You've got some peppers. There's some croutons. Some lettuce. Like this, plus this, plus this, plus this.